The broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome to the EuroSTAR Live Speaker Showcase. Today's presenter is Declan O'Riordan, and he'll be presenting Application Security Testing, Where Did It All Go Wrong? And if you have any questions for Declan about this presentation, or if you want to just discuss application security testing with them, you can do so on Test Huddle, and I'm just going to share a link with you. So if you look in the chat box there, you'll see a link that'll bring you right into this discussion forum, and directly after the webinar we'll be heading over there to look at your questions. I'll now hand you over to Declan. Hello, Declan.
Hello, Dara, and everybody else who's joining us. I'm just going to take control of the screen. Thanks, Dara, and close that off. And yeah, go full screen. Right, my name's Declan O'Riordan, and I've been in IT 33 years, 26 of them in testing. If you want to know more about me, I'm on LinkedIn and Twitter, but I'm going to try and crack on with this presentation because there's a lot to say, and I'd like to get through as much material as possible. So the title of the presentation, Where Did It All Go Wrong? Application Security Testing. Sorry, I'm just getting Dara's screen popping up a little bit there. Just need to make it go away. And I read a figure recently that there was over 1 trillion attempted penetrations of applications in 2013. That seems a little on the high side, but certainly all the other estimates are in the billions. And we can expect more in 2014. But even if it's in the billions, low billions, say, why would people go to the trouble of attempting to do something billions of times? I believe we can conclude it's not because it never works. My assumption is that there are that many attempted penetrations because it often does work, and that many of the failed attempted penetrations are really a reconnaissance for exploits that then succeed later. So this is a big problem, and attackers are leading the innovation. They're coming up with new ways of exploiting applications which defenders then have to respond to. But retroactive security is not really security, and a lot of the money and effort is going into perimeter defense, i.e. the networks, and which are kind of, you can also think of our buildings as perimeter defenses as well. And there's a lot of institutional knowledge in firewall configuration and IDS, which stands for Intrusion Detection Systems, and IPS, which is the better intrusion prevention systems. But just as in medieval times castles relied on thick high walls, attack technology overtook perimeter defenses, and now no more castles get built, and even your great-grandparents would never have seen a castle under construction. They're just, that kind of defense just stopped working in the end. And I'm not saying we shouldn't have firewalls or buildings. I mean, certainly if you left all your applications sitting on servers out in the field, then they'd get trodden on by cows or stolen by hikers, etc. So it's good to have a building with security guards and doors and windows, and it's good to have network security, but that's all about perimeter defense. And there's another level called application, the application layer, and this is where testers should be getting seriously involved. There's a project called the Open Web Application Security Project, OWASP, and they've performed thousands of code inspections, and they say that in close to 100% they find serious security vulnerabilities. So why are we building all these insecure applications? A conclusion I've drawn is that one of the factors is that we're not really testing web applications for security. And I know that until less than 3 years ago I wasn't. From my personal experience, the first internet banking by mobile phone did not have any proper security testing because I did it. The Nokia rushed 50 prototype mobile phones to us at the Woolwich for internet and telephone banking project, which was ahead of its time slightly. And I tested effectively an access control matrix for security. I tested that the roles could not access areas that they shouldn't, in the same way I would have done mainframe testing in the years gone by. And maybe you could forgive that in 1999 because nobody had really explained to me what web application security was about. But unfortunately, I continued working in that way for many years, and so were all the colleagues around me. And okay, maybe my experience is not entirely typical for others, but I suspect there are a lot of people working in our industry, including people listening to this webinar, who are really unsure about web application security testing. And I think the problem is very widespread, not entirely universal. I know that the investment banks in London take it deadly seriously. They've got huge amounts of money to protect, and before any project can commence, the project leader would have to go to their security team, who would then present him or her with blueprints to say, okay, if you're using that database technology with that code language and that code framework, then this is the blueprint you need to look at. Come back in 1 week with your deliberations on how you're going to design security into the system. And also encouraging was I was speaking to a couple of the guys from New Voice Media at the Test Managers Summit recently, and they're obviously going about this the right way there, unsurprisingly. So where did things start to go wrong? I hope my Prezi is actually going to move to the next slide. Yeah, for me, I think a significant moment was the telephone being invented and patented in 1876. But at that time, the telephone network would only make connections. When you picked up a telephone, you'd have to tell a person, usually a female switchboard operator, what number and person you wanted to be connected to. But from 1923, automated exchanges started coming in that eliminated the human element. And that made possible a thing called phone hacking. It took about 50 years for automated exchanges to be rolled out. But electronics enthusiasts, like Steve Wozniak, started building things called blue boxes, which don't have to actually be blue, but they would make dial tones that would hack into engineering, telephone engineer codes that would then allow them to make free phone calls around the world. It's theft from the telephone company, it's illegal, but you know, they were so enthused by their love of electronics and the technology they couldn't help themselves. And Steve Wozniak and Steve Jobs were actually caught in a phone box by the police with their blue box, but managed to talk their way out of it. But their love of building things like the blue box and the electronics side of that led them to build the first Apple computers. Of course, they were a very small player at that time, and IBM were a very big player and introduced the IBM PC running on Microsoft DOS, disk operating system. And meanwhile, there was a lot of converging technology. The Internet Protocol Suite, TCP/IP, was standardized, and the word Internet came into use. The concept of a worldwide network of fully interconnecting networks was introduced. And you know, history takes some funny turns. Steve Jobs had a big personality and was ejected from Apple. So it's kind of curious that the guys that brought you the iPhone were phone hackers, but he was ejected from Apple and cashed in his $100 million worth of shares and bought Pixar as a hobby and started a company called Next. And then, due to a strange quirk of fate, Sir Tim Berners-Lee created the world's first World Wide Web server using a Next computer from Steve Jobs' company. He wrote Sir Tim Berners-Lee wrote the concept paper in '89, but the web server didn't go live until December of 1990. And it was designed for academics at CERN, the colleagues of Tim Berners-Lee, to view static HTTP pages. And it was not designed with any intrinsic security. It wasn't designed for internet banking, it wasn't designed for online shopping, and it wasn't designed for whatever your web applications do. And hence, it's vulnerable everywhere. All security in web applications has been layered on as an afterthought. And if you don't take the time to apply those defenses, then by default your web application is vulnerable. And one of the main problems is not validating untrusted data. That allows all this family of injection problems. We've got XML injection there, SQL injection here, cross-site scripting, which is a form of injection, and cross-site request forgery, which is another form of injection. SQL injection is rated by OWASP as the #1 problem. There's actually many other types of injection, but this probably only exists in about 20% of applications, but it's such a powerful way of exploiting a system, and it's so easy to try exploiting that it probably exists in about 80% of exploits that are successful. And here, cross-site scripting, otherwise known as XSS, is also very prevalent. It's less easy to exploit, but very prevalent in code. Developers need to apply about 7 defenses to prevent stored and reflected cross-site scripting, and another few to prevent document object model cross-site scripting. But they often don't bother, and that's great news for hackers. And just in case you're wondering what XSS and CSRF, cross-site request forgery, are, cross-site scripting is basically a problem when the client browser trusts the web server and all the data that's coming up from it, from the web server, even though the web server is either storing or reflecting malicious code. And cross-site request forgery is the opposite, where the web server is trusting the client browser, even though that has been hijacked by a malicious attacker and is using somebody else's authentication details from their cookies and their session IDs and so on, and their login IDs, to ride their way into the web server, which they will then use to exploit and plant cross-site scripting or SQL injection scripts. So that's pretty bad news. And something that I really want to emphasize is that this distinction between the application layer and the transport layer. Here is the transport layer, and a lot of money is thrown at protecting this transport layer. But the stuff that we work with is usually the application layer here. This is where we design, build and test applications, and defenses at the transport layer can do very little to defend the application layer. I'm just going to move to a simpler 3-layer diagram, although TCP/IP would say it's 5 layers. This 3 layers just simplifies it. But something that's important to realize is that most hackers are aiming here at the web application layer. I know there's people like politically motivated hacktivists get in the news a lot, and they would do something fairly amateur, like a distributed denial of service attack at the network. They'll try and just bring it to its knees, which is not a profitable activity usually. But the people who are economically motivated are more skilled and in larger numbers and more persistent, and those hackers are aiming here. You could think of this as maybe your raincoat, and that's your trousers, and this is your underwear. And if you're not wearing any underwear, you're going to get fully exploited. And the numbers vary from place to place, but 75% attacks around that number are aimed at the web application layer. So if you talk to the salesman for the perimeter defense here at the network layer, the people selling IDSs and IPSs, they'll look you in the eye and tell you so convincingly that they have systems now that prevent application level attacks. You really want to believe them. It's embarrassing not to. But what they say just isn't backed up by any proper research. So, we're testers. We should have to check what people are saying and test their claims. So if I just go to a link here, this is a paper written by the University of South Wales just 1 year ago. And they're looking at the effectiveness of blocking evasions in intrusion prevention systems. And it's not good, because when we look here, I'll just expand that, you can see that one of these well-known evasions was detected pretty effectively by a couple of IPSs, but not at all well by most of them. By most, it's only just over half. And the thing that they're detecting here is CVE 2004-13-15. If we just look that one up, I mean, as the name kind of suggests, 2004 was the year this entry was created. So this has been around for 10 years, and IPSs are still missing it. And yet the salesman will tell you that they have a way of blocking zero-day attacks, which are the strange security language words for new attacks. And this particular evasion is allowing special characters to be inserted. Now, that is a type of attack that can definitely be blocked at the application layer. So when the IPS fails, this is why we should be applying application layer defenses to stop these kind of things. The application layer is the last line of defense, and it's the most important one, because that's where they're aiming. So, yeah, I did want to allow that. Let's go to the next screen. There's evidence everywhere that we're getting hacked. Whoops, sorry, let's go back to that. And Adobe was attacked in October last year, huge amount of data taken. Reuters estimate that almost every Fortune 500 company in America has been hacked and likely won't know until 6 months after the breach. Well, 6 months is maybe an average figure, but there are many people and businesses who don't realize for years, if ever. I mean, Angela Merkel, she only realized that she'd been hacked 8 years after it happened, maybe 9 years, and that was because of a whistleblower called Edward Snowden. If he hadn't told his story, and I'm assuming it's true, then we wouldn't know anything about that. In fact, there's been a mass population surveillance exercise, and we wouldn't know anything about it probably. Bitcoin had the Bitcoin exchange called MTGOX hacked about February this year. That business, MTGOX, was totally destroyed, and I would have thought that if another Bitcoin exchange is hacked, then the whole of Bitcoin will be destroyed. And yet last year, that was the up-and-coming currency that everyone was excited about. Heartbleed symbol there, obviously everybody's heard about that one. If you're interested in these kind of stories, you could actually go, there are plenty of places you can look. There's a link here, I'll just go to one. Threat Post, you know, they're covering the story of the US indicting five Chinese army officers for alleged cyber espionage. Go back into here. And I've also put a link on my presentation to the register, which I think a lot of hackers treat that as like the Sun or the Daily Sport or something like that. But it is quite fun to read. Okay. So here's a problem. Ignorance has become the norm. And software security, meaning building self-defending applications, has become confused with security software, meaning like firewalls, intrusion prevention systems and so on. They're not the same at all, but the language is becoming confused. And very little application security is taught to IT students or employees. In fact, I've never been asked at an interview if I knew anything about application security, and when I've done interviewing, I've never asked anyone because I just assume they won't know about it. According to Cisco 2014 annual security report, there are 1 million security positions unfilled. So the things that those 1 million people will be doing, they're just not happening. Just to help hackers, there are 13 countries that actually outlaw encryption. That just makes it really nice and easy, but in countries like Britain, where encryption is not outlawed, there's still a lot of confusion about encryption and how to apply it correctly, so it's often misapplied. According to the Massachusetts Institute of Technology Research, there are 700 kinds of software weaknesses that the developers can make mistakes with. And yet 60% of developers are apparently not concerned about security. and 2/3 of organizations don't know which components are used in their applications. The Open Web Application Security Project believes that many organizations choose not to know about the security of their code. There's a strange kind of human element to this, that if you were to rationally look at the problem, you would probably decide you had to do something. And if you decided that for some reason you weren't going to do anything, your name might be attached to the problem. The day you get hacked, you'll be like, oh, who decided we shouldn't do anything? All right, yeah, that guy's got to go. But if you completely ignore it, then maybe it's hard to finger the person who made the mistake of not building any application security. I don't know, that's just a personal feeling. I've highlighted the last point in bold because I think this is a common mistake. Systems are designed and tested to do what the customer wants, not what a hacker can make the system do by exploiting the weaknesses. So yeah, we test back to requirements, but our business analysts and systems analysts and architects are making a terrible mistake if they don't include use cases to build in security by design. And by that I mean securing the weakest link, defending in depth, failing securely, granting least privileges, separating privileges, avoiding complexity, not sharing mechanisms between users, be reluctant to trust, assume your secrets are not safe, mediate completely, i.e. checking every access and object every time, make security usable so that people don't try and work around it because it's a nuisance if you do it badly, promote privacy, and use the resources you have. So I think it's important to try and do that. Now, the way things are at the moment, I think security exists in silos of expertise. There are people, generally the people who are configuring the firewalls, who they have a lot of expert knowledge in their typically perimeter defense area, but they're not sitting in the project teams telling coders, developers how to code or testers how to test, or even much of telling the designers how to design. And that's probably because a lot of people working in the project teams don't really care. They don't care about application security as just another nuisance, and they'd rather just do the stuff they're used to doing. And also on the business side, the senior management, they don't like paying for secure code because it looks the same as insecure code, and if it costs any more, you know, they'd rather just have the cheap thing. When they buy intrusion prevention systems, they can see things appearing on the screen. Yeah, it's like blocking this and it's blocking that, and it stopped such and such a penetration. But application security is a bit more intangible. It's harder to get to grips with the fact it's actually doing a useful job. But I think of it as like, you know, when I first started driving a car, I didn't have to wear a seatbelt, but then a law came in telling me I should, and for a little while it was a nuisance putting it on. But now I never get in the car and think, oh, such an overhead putting a seatbelt on. It's just automatically doing it. I think the same thing applies to application security. I mean, once you've learned the basics, you just do it all the time without thinking about it. So something that I think a lot of managers like to reach out for is ISO 27001. This is an information security management system, which if you implement it, you'll be audited on, and it will verify, the audit will verify that the procedures you have defined have been applied correctly. I actually don't like these books, but you know, I'm not going to say nasty things. But I would say that my interpretation of ISO 27001 that I've verified with a few people, and I believe it's correct, is that if you don't define a process for testing application security or a process for developing using secure coding guidelines, you can breeze through an ISO 27001 audit because you know, it's only checking the processes you have defined. And it's not really prescriptive at a detailed level. It's all very high level, the stuff it expects you to define. So I'd say it's good to have an information security management system, but it's better to build security in, build secure systems, and then passing an audit will come easily. But you could easily have the opposite approach of having an audited application security, having an audited information security management system, but not be secure, and yet give the impression that you're secure. So it's something of a fig leaf. Be careful with this one. And around this time, I think many people listening will be thinking, oh no, it's not only a big subject, it's complicated. So, I don't like that. It's tempting to look for a panacea, some sort of silver bullet solution where you think, well, if we just do this one thing, then everything will be okay. But actually, the solutions and defenses are very diverse, and that's frustrating for human beings. I understand that, but it's just the truth. So it's tempting to try and delegate the problem. So maybe you should delegate to scanners. Let's have a look at that. When the people who sell scanners, again, they'll tell you, much like the perimeter defense stuff, that they're very good. But here's the results of a scientific comparison of scanners. And VS 1.1, Vulnerability Scanner 1.1, and Vulnerability Scanner 1.2 are different versions of the same scanner. But they're bringing up nearly 40% false positives. And Vulnerability Scanner 2 isn't bringing up any false positives, but look, it's hardly finding anything, so it's bringing up a lot of false negatives. And a very concerning thing is that these just 4 scanners only have 21 vulnerabilities found in common. So depending on which scanner you use, you're going to get different results. Now there's a researcher called Shay Chen who's very kindly allowed me to share his research findings in this presentation. So I'll just click on a link to that and look at the free open source scanners. Now I'm trying to remain vendor neutral here, but if you were to look at this, and you're very welcome to do if you follow my presentation afterwards, follow the link. This is the better end of the free and open source scanners, and yet WIVET, that stands for the Web Input Vector Extractor Teaser. That's if you give it a URL, it tries to extract as many input vectors as possible to increase the coverage of the attack surface. A lot of these are very poor in that area. SQLI, SQL injection, not very good. RxSS is the reflected cross-site scripting. LFI, path traversal, and RFI is the remote file inclusion. Now these, if you look at these results, and if we go down the bottom of this big long table, the results are really terrible. I think you should be aware of this if you're thinking of implementing a scanner at your commercial workplace. So the free ones and open source ones, very shaky. You look at the commercial scanners, okay, this is better, this is definitely better, but are you getting what you pay for? The one at the top of the list is pretty good, but the cost is very high, whereas if you were to look at the number 3, it's pretty similar in terms of quality. The price is a lot lower. So I just, I'm not saying that these, I'm not going to tell you which one to get, but certainly bear in mind this kind of information if you're thinking of applying a scanner as one of your layers of defense. Okay, and let's think about penetration testers. Let's go there. So I know I've worked on a lot of projects where people think if you just bring in penetration testers, typically at the end of the project, that's going to sort out finding the application security bugs. But imagine if you were given the same brief for testing in general, where they said, you're a functional tester or a functional test manager, we're going to have like 20 developers work on something for a year, and in the last week you can start testing. You can learn everything about the system you need to know and find all the bugs. It's incredible that you'd think that would work. What I'd say is, yes, penetration testers are experts in security, definitely. But you're the experts in your systems, and if you could get even just one of your testers to learn Metasploit, which is a very useful tool for finding exploits in the system, for being a hacker effectively. That would be a huge step forward in building secure systems and testing security. And try to think of these scanning tools as like spelling or grammar checking tools. You know, they don't understand the context of the applications you're building in your organization. Much as like if you put Shakespeare prose through the Microsoft Word spell and grammar checker, it throws up objections everywhere to Shakespeare. But if you put like a children's storybook, you know, for a 5-year-old through it, it says it's great. It says that that's better English than Shakespeare. And yet there's a lot of people out there, paying customers, who much prefer Shakespeare to children's books. And there's a huge industry of Shakespeare stuff. So it's all about the context of the applications. And these general purpose scanning tools just don't get that. So what can we do? Well, I believe the solutions are within our reach. We could tackle projects with the end in mind. We could build embedded security into applications by design. We should have like a win-win equation for all parties where the security adds value rather than cost to the project, so that I believe over time more and more customers will wake up to the fact that they'd rather be doing business with companies that respect and secure their data than those that don't respect it and lose it and let hackers get hold of it. But in any case, security should be something that is not seen as a burden. It's something that's necessary and useful and can be designed to be not onerous to use. We should use proactive and preventive security design techniques to avoid reactive and remedial tactical responses to strategic security issues. We should build apps to be secure by default through good coding practices and least trust policies. Security should be a consideration at every stage of engineering, from the requirement specification to maintenance to decommissioning and data archiving. And all applications must be self-defending. Now, at the EuroSTAR conference in Dublin this November, I'll be presenting my what, why, who, and how of application security testing. That's one way you could help yourselves to understand the subject and go back to work with useful working knowledge on how to build and test secure applications. Unfortunately, there is no silver bullet. The real defenses are diverse. So yeah, you need a building, you need network perimeter security, and you need scanning tools, and you need to build secure applications and test them. And there's a place for penetration testing experts and for your own team and testers to learn a bit of hacking. So people think it's strange sometimes that you know, I've got a name like Declan, and yet I don't speak with a proper Irish accent. And there's a historical reason for that. That my father left. He grew up in Dublin in a house in De Courcy Square, about 15 minutes walk from the conference centre in Dublin. And he played football for the Bohemians, and he made a decision in 1942 to join the RAF. And you know, sort of embarrassing to talk about war stories, but you know, he was certainly not in favour of war at all. He came out of it a very strong pacifist, but he signed up and he did his duty, even though he was a volunteer. That's in there. Just get that screen there. But the reason I show this picture is that this guy here is my dad. He was in what's called a Pathfinder squadron. I think there's a useful concept there for a war-winning strategy. Although, you know, there were many strategies led to the end of World War II, but you know, one of them was to light up the targets and to show the main force coming behind where they should be going, what it is they needed to tackle. And I like that analogy. I think that there's not enough testers who know what they're doing in application security testing. So if you do, or if you can learn it, then try to tell as many people as you can working on the projects how to do application security testing. And you know, you can go out there and try and work it out for yourself. You could teach yourself. But what I'm suggesting is that you come to Dublin, and I'm going to hand out my application security testing procedure to anyone who's interested, which will at least get you started. Some people probably already working around this, the OWASP top 10, the top 10 vulnerabilities that have been identified by them for application security. But if you haven't already started, this is a very important place to begin. It's almost impossible to leapfrog tackling these 10 risks, because if you do and go straight to something like advanced persistent threats, for sure, you know, the majority of attacks are going to be coming still at the injection level and the cross-site scripting level. So I provide a paper that describes what these things are and how to test for them. But when I started doing this at work, I realized that actually, you know, it was too easy because the developers didn't know what they were doing. There are some developers who know a lot about it, but a lot of developers are actually quite in the dark on application security. So I wrote development guidelines, and you know, it'd be great if you all come to Dublin and meet me and hear my presentation. But if you don't want to wait 6 months, even this screenshot here would give you something you could go back to work with, you know, in half an hour's time and start to tackle a problem with. You could say, you know, what are we doing to the developers or to the architects and the systems analysts and business analysts? What are we doing to prevent injection? And they should give you an answer like, we use prepared statements, otherwise known as parameterized queries, and these are database independent, or we're storing procedures on the database to prevent injection, and we're escaping special characters, and maybe we're also using whitelists, so that's less effective. And that would be good to hear, but there's a chance they won't say that. It's a pretty big chance they won't say that. And certainly if you were to tackle them on cross-site scripting, which is the number 3 vulnerability in the OWASP list, but it's actually probably the most prevalent flaw in applications. If you were to ask them what they're doing to prevent cross-site scripting, they should give you 7 answers to prevent stored and reflected cross-site scripting, which basically rule 0 applies all the time. Never insert untrusted data except in allowed locations. And then rules 1 to 6, HTML escape, attribute escape, JavaScript escape, CSS escape, and URL escape. They should definitely know this, but they probably won't. And sanitized HTML markup with a library. Now, maybe a switched-on one would say, oh, yeah, but that's going to affect performance. So then you could have a design discussion about whether to apply that or not, or how you apply it intelligently. Rule 7 is about preventing document object model based cross-site scripting. There are some bonus rules as well, but what I expect is that if you were to tackle your developers on this, a lot of them are going to say, look, I just don't know how to do it. So that's why it's good to come to Dublin and get the application security development guidelines. And you know, also talk to your architects and business analysts and systems analysts. Come on, let's get some use cases into the project for security, not just what the customer is specifying as requirements, because they have no idea about application security other than, yes, we'd like it to be secure. They cannot express anything beyond that. So it's the project team's responsibility to design that security in. So there we are. I think, you know, the situation's bad, but it's not hopeless. We can fix this. And you know, that's what EuroSTAR is all about. So I hope many of you come to the presentation, and I hope that in future years we'll look back on this as, well, you know, do you remember the time we used to put web applications live without testing for application security? You know, it'll be laughable, I hope. So there we go. That's the end of my presentation, and I'll be on the test huddle for anybody who's got questions or statements or war stories or whatever they'd like to to tell. So thank you very much, and over to you, Dara.
Thank you very much, Declan, for that presentation. I'm just going to open up my screen here again. So if you just bear with me now for 1 second. Okay, I'm just going to share the link one more time with you guys. And this link here, if you look in your chat field, you'll have a link that'll bring you right into the discussion forum, and you can ask Declan any questions you have about his presentation, and you can discuss then as well security testing there. And Declan's presentation at the conference in November will be what, why, who, how of application security testing. And tomorrow we have another webinar with Christopher Nordstrom, and he'll be presenting why every system test department should have a test developer or two. And as Declan had there in his last slide as well, the super early bird deadline is next Friday, that's the 30th of May, and this super early bird offer will save you up to €430 on your conference ticket, and you can make an even bigger saving if you register a group where every 5th attendee goes free. We're now going to move over to Test Huddle, and I want to thank Declan for his presentation once again. The webinar is now over, and I'll see you on Test Huddle.